Okay, let's look at homework 3.6, 3.7, number 13. Just the finding the point of inflection. All right, so let's do that. All right, so in order to find the point of inflection, we need to take two derivatives. So first derivative, we've done it before, but I'll do it again. Right, so we have 5/3 x to the subtract 1, so it's going to be 2/3 power. And then negative 5 times 2/3 is 10, 10/3 x to the negative 1/3. Right? Then another derivative. So y double prime is equal to, right, let's say put 2/3 in front, so 2 times 5 is 10, and 3 times 3 is 9. Then you have x to the subtract 1 from the power, so negative 1/3 from there. All right, then put negative 1/3, so it's going to be positive, and it's going to be positive 10/9. Right, x to the, right, so we have to subtract 1, so it's going to be negative 4/3. Right, so we need to clean this up a little bit. So you have so that's equal to, right, so first thing is I'm gonna pull out 10 to the 9th. Right, so x to the negative 1/3 is 1 over x to the 1/3 power. It's kind of hard to see, so this is 1/3 power. All right, then plus, you're going to have 1 over x to the negative, negative, so it's a 4/3 power. Right? Right, to get the common denominator, so I'm going to multiply top and bottom by x and x. Right, that way we can write it as, right, so you have a 10 over 9, right, and on the bottom you will have, right, x to the 4/3 power, right, then you have x from here, and a plus 1, right, so set that equal to 0, we can get, right, so this guy is, let's see, x minus x plus 1, so it's going to be x equals negative 1 from setting that equal to 0. Also, f double prime is undefined when x equals to 0, so we're going to probably look at that. So since, you know, y double prime of 0 is undefined, just like f prime of 0 was undefined, so we're going to look at x equals 0 too. All right, so we do a number line, so number line, so we're going to put two tick marks, one for negative 1 and one for 0. Then we look at the sign of y double prime, right? So here you can try something smaller than negative 1, so I'll try negative 2, right? If you plug in negative 2, all right, so the bottom guy is always positive because you have a 4th power involved, even power. All right, so we just have to worry about the top. So negative 2 plus 1 is negative. So negative divided by positive is negative. Right? Between negative 1 and 0, we'll try negative 1/2. Right? Negative 1/2, bottom is positive. Negative 1/2 plus 1 is actually positive. So positive over positive is positive. right? Let's try something bigger than 0. So we'll try 1. All right, 1 plus 1 is positive. The bottom is always positive, so it's going to be positive. Right? So there's no concavity change, so y is going to be here, concave down, and here, concave up, and here it's still concave up. So there's no concavity change here, so there's no inflection point, but here there's a concavity change, so you have a inflection point there. All right, so we just have to find the corresponding y value, so we plug in x equals -1 into the original function. You will get x to the 5/3, right? Sorry, not just x. We're gonna plug in -1, right? -1, right? Minus 5 times -1 to the 2/3 power, right? So this is going to be -1 to the 5th power would be -1, and then a cube root is going to be still -1, right? So -1 squared is 1, then cube root of 1 is 1, so it's -5. So which means that it's -6, right? So we found the one inflection point. Inflection point is -1, comma, -6. Right? So let's check that. Right? It's going to be -1, comma, -6. Right? Let's check the answer. All right, it came back. Let's see, we got the point of inflection correctly. All right, that's it. I hope that this was clear.